In the last video, we learned what y equals 1 over x actually looks like by making a table. And I redrew it right here, and I want to point out 3 key features that are going to help us graph other rational functions like this. So 3 key features of this graph. So first of all, just like you can recognize a parabola by shape, you see, oh, it looks kind of like a U and that sort of thing. Absolute value looks like a V, and so on. You should recognize this sort of graph by shape. If you see some sort of bow tie looking graph, and they do get more complicated looking later on, like if you do word tricks pre-calculus, but for our purposes, most of the rational graphs we see are going to look kind of like this. Basic, 2 pieces to them, got some asymptotes going on, and so on. The first thing I want to point out here, which I did mention in the last video, is that we have a vertical asymptotes right here. Our graph veers off and does not actually hit x equals 0. So the first thing, we have a vertical asymptotes at x equals 0. Secondly, our default horizontal asymptotes is right there at y equals 0. So these graphs are going to have 2 asymptotes for our typical translations of our parent function. And for the final thing I want to point out here, which is kind of a nice trick back from earlier on when you took, in first semester, when we were graphing parabolas and that sort of thing. Say I were to start out right here, kind of at the center of my problem, where I drew that yellow circle at 0, 0. That's kind of like this center point right here. If I were to go up 1, over 1, I landed on my graph. Notice I had a 1 right here. There are other ways of doing these graphs, but this is a nice little trick that's going to be kind of helpful. If I go up 1 over 1, and then I went up and right here, if I backtrack and I go down 1, left 1, I also land on the graph. That's going to come out to be very big and very helpful in graphing slightly tougher examples. So what I'm going to write here is that our up 1 over 1 trick works. And I'm going to show you 2 examples here. And we'll be able to take a look at how these actually play out. We're using these 3 rules. So this example obviously looks a little tougher than the last one. We've got some extra movement going on there. We've got pluses and minuses. But the good news is the same rules we've used all year still work on these problems. First thing I'm going to target is this plus 2 right here on the inside with the x. Now you should be very good by this point at saying where that's going to move my graph. So you should ask yourself right now where it's going to move, but hopefully you did decide that will move your graph left 2. So just like with the logs, just like with the exponentials, we're going to move our asymptote right now. And the left 2, if you have a horizontal line and you move it left to right, maybe I move it over here, it's in the same spots. Like it's still the same position. If I had a vertical line though, and I move it left to right, I get a whole new line. So remember, vertical, we care about left, right. So my vertical asymptote is going to be at negative 2, left 2. So I'm going to draw that in. Once I have that in place, this minus 3 over here, as hopefully it's on the outside, you guys know, will move your graph down 3. Now with the vertical asymptote, who cares about up, down? But when you have a horizontal asymptote, that's going to change where we are at. So instead of being at 0 on this one, my horizontal asymptote is down at negative 3. So I have 2 new asymptotes in this problem. Now, to make my graph, I need to have some points to be able to see where my pictures actually go through. I'm going to say for our purposes right now, 1 point on either side of the bow tie is good enough for me. And if you recall, in the last example, from the intersection of those dotted lines, from the intersection of my asymptotes, I went up 1, over 1, and I landed on my graph. I'm going to do the same thing right here. My new kind of center of the problem is right down there at that green circle. So if I go up 1, over 1, I should have a point on my graph. Up 1, over 1, the same way I did on the last example. Now I'm going to backtrack right now, and I'm going to go down 1 and left 1. Just to get the other half of my bow tie, I'll get a point right there. Once you have those points in place, you can pretty much use the asymptotes to guide your graph. I know that it starts out really high like this, kind of tails off on this side, and it's going to do likewise on that side. And there's my graph, completed, looks pretty good. So those 2 pieces make my graph. Going to do one more problem in this video, and on this one here, I'm going to see what happens when we have some extra stuff going on, like with a number, negative sign out front, a number on top. Before we get there, though, let's look at how our graph moves. We see from this that our graph's going right 1. So my vertical asymptote is going to go right 1. And I see from my outside that I'm going to go up 4. So that asymptote is moving up 4. Looks like this. Now, on the last problem, we had a 1 up top. So we went up 1 over 1 and got a point. We did the reverse. Here, if there's a negative sign out front like this, you can drag it up and put it with the number. There's really a -2 up top, if you think about it that way. So you can pretty much ignore this part. There's just a -2 up top now. If we have a -2 up top, what I'm going to do for my center point, which is right there, is I'm actually going to go down to right 1. Kind of like you would do, like using our shortcut with our up 1 over 1 trick, except it's negative, so we're going to go down to right 1. And when we do that, we're going to get a dot right here. So I know what this part of the graph is going to look like using my dot right there. Once that's in place, I need to make the other half of my bow tie. And in order to do that, I'm going to backtrack. I went down to right 1. So I need to go up 2 and left 1. I get my point right there. And from that, I can make the second part of my graph, and I am good to go. There is a rational function using the same rules we've been talking about all along.